For 4.5 billion years, Mars made no sound that any living thing could hear. Not because it was silent. The wind moved. Dust lifted and swirled and settled. But there was nobody to hear it. No ear pressed to the ground, no brain translating pressure waves into meaning. And then, on the 19th of February 2021, a microphone on a rover the size of a small car switched on in the thin Martian morning air. What it recorded was not silence, it was wind. And humanity heard another planet for the first time. That moment was the product of a specific argument made by Roger Wiens, a geochemist and planetary scientist at Los Alamos National Laboratory who led the SuperCam instrument team on the Perseverance rover. SuperCam is a laser-equipped spectrometer that can vaporize a patch of rock from up to 7 meters away and analyze the chemical signature of the resulting plasma. Attached to it is a microphone. Wiens argued for years that recording the acoustic environment of Mars would yield unique data about the density, composition, and turbulence of the Martian atmosphere. It would also, he noted in the understated way of someone who has spent a career writing grant proposals, be extraordinary to hear. He was not wrong about either claim. For most of human history, Mars occupied a peculiar position in the imagination. In 1877, the Italian astronomer Giovanni Schiaparelli mapped linear features on the Martian surface he called canali, channels, which English translators rendered as canals, implying construction. Percival Lowell spent 20 years from the 1890s onward arguing that Mars was home to an ancient civilization engineering a planet-wide irrigation system. His books sold widely. His science did not survive contact with better instruments. The spacecraft era replaced Lowell's inhabited Mars with something harder to romanticize but stranger in its own way. Mariner 4's flyby in 1965 returned images of a cratered, apparently dead surface with an atmospheric pressure less than 1% of Earth's. Then Mariner 9 arrived in 1971 and, when the global dust storm obscuring the surface finally cleared, revealed a world of continental-scale volcanoes, a canyon that would stretch across the continental United States, and valley networks that looked unmistakably like river drainage. Mars had once had liquid water. Everything that followed, Viking, Pathfinder, Spirit and Opportunity, Curiosity, refined that picture without overturning it. The disruption came on the 30th of July, 2020, when a rocket lifted off from Cape Canaveral Space Force Station, carrying the most capable Mars rover ever built. Perseverance weighed 1,025 kilograms, carried 23 cameras, 2 microphones, and 7 scientific instruments. It arrived at Mars on the 18th of February, 2021, executing a fully autonomous entry, descent, and landing sequence, the 7 minutes of terror, engineers call it, during which the signal delay between Mars and Earth means mission controllers can only watch the telemetry, not intervene. The landing was perfect. Perseverance touched down in Jezero Crater, and within days it began revealing a world that was specific, detailed, and nothing like the romantic projection. The Martian atmosphere is 95% carbon dioxide, and sound travels through it differently from how it travels through Earth's nitrogen-oxygen mix. The speed of sound on Mars is approximately 240 meters per second, 1/3 slower than on Earth. But Wiens and his team discovered something the models had not fully predicted. At high frequencies, sound travels faster on Mars than at low frequencies. This property, called acoustic dispersion, had been known theoretically but never measured on another planet. It means that a complex sound on Mars would smear across time as its components arrived at different speeds. The acoustic environment is not just quieter and thinner. It is physically different at a level that changes how information propagates through the air. The recordings also captured weather. On the 20th of July, 2021, Perseverance's cameras recorded a dust devil crossing the crater floor, a column of rotating dust formed by uneven solar heating of the surface, the same mechanism as on Earth, but scaled up dramatically by Mars's low atmospheric pressure. Some Martian dust devils have been detected by orbital spacecraft at heights of more than 8 kilometers. They carry less kinetic energy than a hairdryer, but they have been churning the planet's surface for billions of years. On the 9th of November 2021, Perseverance recorded a Martian sunset. Where Earth's sunsets are orange and red, Mars's sunsets are blue. The planet's atmosphere is laden with iron oxide dust particles that scatter and absorb red light while allowing blue light through. The result is a blue-gray aureole around the setting sun, fading into a butterscotch sky at the horizon. It is not a rendered image or a color correction. It is what physics does in a different kind of air. Jezero Crater was not a random landing site. It was selected because it preserves a fossilized river delta, a fan of layered sedimentary rock deposited where a river once entered a standing body of water. Orbital spectroscopy identified carbonate minerals along the crater's inner rim, minerals that form in liquid water and that are known on Earth to preserve organic material with exceptional fidelity. Ken Farley, the Perseverance Project scientist at the California Institute of Technology, has described Jezero's delta as one of the most promising targets for biosignature preservation anywhere on the Martian surface. The rover's Sherlock spectrometer uses deep ultraviolet laser light to detect aromatic organic compounds in rock and soil at concentrations of parts per billion. The Pixel instrument maps the elemental composition of rock surfaces at sub-millimeter resolution, looking for the chemical gradients that microbial activity produces and that geochemistry alone does not easily replicate. And Perseverance's MOXIE experiment, a toaster-sized device that heats Martian carbon dioxide and electrochemically splits it to release oxygen, proved that a crewed mission could manufacture breathable air and rocket propellant from the planet's own atmosphere. In its early tests, MOXIE produced approximately 6 grams of oxygen per hour. A scaled-up version, roughly 100 times larger, could support a human crew and eliminate the need to launch ascent propellant from Earth. Meanwhile, Ingenuity, the small helicopter that arrived strapped to Perseverance's belly, became the first powered, controlled aircraft to fly on another planet on the 19th of April, 2021. Its rotors spin at between 2,400 and 2,700 revolutions per minute, roughly 5 times faster than a helicopter of comparable size would need on Earth, just to generate lift in the thin air. By early 2026, it had completed more than 70 flights covering more than 18 kilometers. The honest state of the science is this. We have strong evidence that Mars once had liquid water, a thicker atmosphere, and chemical conditions that resemble early Earth during the period when life first appeared here. We have zero confirmed evidence that life ever existed there. Mars's wet period lasted approximately 500 million years, roughly the same span within which life appeared on Earth. Whether anything emerged before Mars's magnetic field collapsed and its atmosphere stripped away is not a question any current instrument can answer definitively. The geology of Jezero's delta is among the most promising environments for biosignature preservation anywhere on the planet. Carbonates, silicates, and sulfates have all been detected in the delta stratigraphy by orbital spectroscopy, and all three are known on Earth to entomb organic material and hold it intact over geological timescales. But preservation requires that something was once alive to be preserved. Whether that condition was ever met on Mars is the question that remains open. The samples sealed in Perseverance's titanium tubes, cached on the Martian surface at a site called Three Forks, may eventually answer it. Mars Sample Return. The mission to retrieve those tubes and bring them to terrestrial laboratories capable of the kind of precision analysis that cannot be miniaturized into flight hardware, faces funding uncertainty that has pushed its timeline beyond the mid-2030s. The planetary science community's most recent decadal survey ranked it as the field's highest priority. The scientific case is unambiguous. The budgetary case is harder. The tubes are waiting, patient in the way that only inanimate objects can be. What we know with certainty is that we have fundamentally changed our relationship to Mars. It is no longer a telescopic disk, a canvas for projection, or a placeholder for whatever we needed it to be. It is a specific place, with specific weather, specific acoustics, specific geology, a world whose sunsets we have watched, whose dust devils we have filmed, and whose wind we have heard through a microphone on an otherwise empty plane. We know what its air sounds like. We know the color of its sky at dusk. We know the shape of the delta where a river once met a lake, and we know the chemistry of the rock that river left behind. That is not a small thing. It is the result of decades of engineering, accumulated mission data, and a scientific community that kept refining its questions even when the answers were slow to arrive. The microphone that recorded the Martian wind on the 19th of February, 2021, was picking up pressure waves that had been crossing an empty landscape for billions of years before any mind existed to receive them. The wind did not know it was being heard for the first time. The planet was not waiting to be discovered. It was simply there, doing what physics does. And then a mind did receive it. Whatever Mars once contained, whatever is sealed inside those titanium tubes, we have heard the place. We are part of the same universe as the world that made that sound. That knowledge does not require a confirmed biosignature to be extraordinary. It is already extraordinary. The rest is a question we are still patient enough to pursue.